Alright, this is a very quick review on quadratic functions and equations. Now, when you're talking about quadratic functions or graphs, we've got two forms. First one is standard form. Now, standard form you're going to see is y, or f of x, equals ax squared plus bx plus c. Now, you're usually going to see this in textbooks or when they're writing equations down to solve. Now, the next form is your vertex form. And this is going to be y equals the same a times the quantity of x minus h squared plus k. Now this form has more jobs. You can use this form when you're talking about translating the graphs up and down, sideways, left. You can always see where your graph's going to be. Now this h number, its job is to tell you how far your graph goes sideways. And it's always the opposite number. The k translates your graph up and down. And your a, if you have a positive a, that tells you that your graph is going up. If you have a negative a, your graph is going down. A also adjusts the width of your graph. Now with those basic kind of vocabulary terms, we can go ahead and talk about how to use some of the specific parts of the graphs. Now with any quadratic graph, you've got a whole bunch of important pieces. Now, I'm thinking the most important piece would be the x-intercepts. Now the x-intercepts can have a whole bunch of different jobs. Now if we decide that this is going to be at the number 3 and this is going to be at the number 1, one of the words that we're going to use to describe those are the zeros. Now the zeros are usually written as coordinates, so that would be the coordinate 0, negative 1, and the coordinate 0, 3. Now another name you're going to have for this is, people will call these the roots. Now if you're ever asked what the roots are, it's usually just a list of x's. So in this case, x would equal a negative 1 and a 3. This is also the form you're going to see solutions in. So if we're using a graph to solve a quadratic equation, you're going to need the roots in order to find the solutions. Let me see. Oh, we can also use this graph to figure out factors. Now, these factors are not necessarily on the graph, but we can get the numbers. Now, if I wanted to factor a quadratic equation, and it's an equation that hits at those roots, I would have factors of x minus 3 times the quantity of x plus 1. Now, if you're using factors with your graph, you have to remember that the factors are always going to be the opposite number. Now the next important piece of a quadratic is going to be the vertex. Now the vertex you're going to see in two different forms. The first form is, if you're looking in vertex form, you're going to have an h and a k. And you're going to be able to get that straight from the equation. There's not going to be any changing, there's no solving, there's no nothing. Now if you happen to have a standard form for your vertex, you're going to have to do a little more calculating. Now in your vertex from standard form, and let's go and write ourselves a note that this is from standard form. Okay. Your h, or that x number, can be found by using the opposite of b over 2 times a from standard form. Then your k, you're going to find that by substituting your x into your equation. And again, you can see that as k, you can see that as y, you can see that as x. All sorts of different methods that you'll need to keep track of. Now the last important thing that you need to know about for quadratic equations would be this, and that's the ever important y-intercept. Now you cannot tell the y-intercept from vertex form. The only form you can tell the y-intercept is that's always what your C is, and this is from standard form for only. I hope I said that last time. It's from standard form only. Alright, let's go ahead and talk about ways to solve your quadratic equations. There's several different kinds of solving. Now, right now, we're just going to go ahead and list them, and then we'll talk about each way to do this. Now, if you have a really pretty equation to graph, then you can always solve these by graphing. And then you're just going to figure out where your graphs hit. Another way to solve these would be factoring. The third way is completing the square. And then the last thing we're really going to talk about is the quadratic formula. Now, this is usually the order that I try to solve equations, especially if you're just given the option, solve any way you want to. But there are some things that you need to keep in mind. Now, with graphing, you're going to want a pretty solution. Okay? You cannot find any decimals with graphing. You can find it if you have an equation that hits at 3 and -1, but other than that, there's not much you can do about it. Now, factoring. These also need to be pretty. They obviously need to be factorable. So you're only going to use these for pretty numbers and possibly fractions. Now, completing the square. You can use these for radicals. Sometimes it doesn't even matter if you have perfect squares or if you have nasty squares. The only thing is you can't do anything with an imaginary number. Now, the quadratic formula you can use for all types of equations, but it is one of the longer methods. I would use a calculator for this. Now, you don't have to use a calculator, however, that is definitely the easiest way to go. Now, when your calculator spits this out at you, you will need to find the zeros, and you'll find that that's going to be at a 1/2, and that's going to be at a 3, which means my solution to 2x squared minus 5x minus 3 equals 0 would be the answers of x equals -1/2 and a 3. Now, the next thing that we can do with this equation is we can factor it, but you have to remember how to factor. So if we start with the equation of 2x squared minus 5x minus 3 equals 0, you might notice that we have an a in front of our trinomial. So we're going to have to use the trinomial method. Now, what I want to do is I'm going to multiply the first number and the last number. So 2 times -3 is a -6. Now, what I want, and this is just a way to organize my thoughts, is I want a number that will multiply to -6, but I'm going to need to add to the middle number. So if I need things that are going to combine to a -5, we have several different factors of 6, and I did 6 for a reason. I keep using that line. I did 6 for a reason. Now, if you're trying to find factors of 6, you're going to have 1 and 6 and 2 and 3, and all of them can be combined to make 5s. So when you're looking at something like this, you have to pay attention to signs. Now, if you make a -2 and a -3, that will add to a -5, but it will not multiply to a -6. It multiplies to a +6. So the 2 and the 3's can't work simply because of this negative on the 6. You have to use a -6 and a +1 in order to get your -5. So when you have something like a 6, a 36, a 12, something with lots of different factors, you need to pay attention to signs. Now, once we figured out the numbers that can go and do the multiplying and adding the way we want them to, you're just going to put them in a factored form. So you're going to go x minus 6 times an x plus 1 now equals your 0. And we're going to be using a method called bottoms up, and this is the way we take care of that too. Mathematically, what we were doing is ignoring it. Now, once you have a coefficient in front of a, you need to put it back into your equation by dividing both of those new factors by the a. Then you need to see if you can reduce. 6 over 2 becomes the number 3, so I have x minus 3. X plus 1/2 does not factor, or reduce, sorry. So we can leave that like that. Now, if you recall from the last page, my answers were a -1/2 and a +3. In this page, when we go ahead and use the zeros product rule, which means that if I'm looking at any of my given factors, I want one of this parenthesis to be 0. So if you're just looking at here, x would need to be a +3. If you're looking here, x would need to be a -1/2. So that's where our solutions come from. X is going to be a +3 and a -1/2. And I know we already knew that. Oops, wrong bracket. We need squigglies because we're making a list. I know we already knew that, but we needed to make sure you knew where the method comes from. Now, on a side note, if you are factoring only, and there is no equal sign, which means you're looking at something like this, x minus 6, and then your x plus 1, no 0, and we go ahead and take care of the bottom number. Now, the final answer for this one, you would need to reduce and get your x minus 3. However, if I'm not solving and I just want the new parentheses, you are going to need to move the bottom up. So the factors are actually x minus 3 and 2x plus 1. So you need to pay attention to what the directions are actually asking for. If I have an equal sign and I need roots, I need the fraction. If I have no equal sign and I need factors, I don't want fractions. Okay, the next method is going to be completing the square. Now we're again going to use the exact same equation we've been using, so we know the answer. We just need to learn the method. So we have a 2x squared minus 5x minus 3 equals 0. Now when you're completing the square, this is where you're trying to find the perfect parenthesis so that when you take a square root of something to get that x all by itself, you end up with perfect numbers to be able to do that. Now, once you take the square root, you're going to remember on this method you have a plus and a minus. Now, another thing you need to remember is if I have an x plus 3 squared equals 10, it doesn't really matter, and I want to get rid of this square so x can get out of the radical, I can take the square root here, and this x square root and the square make each other go away, so I'm left with that x plus 3. And you move the radical to the other side. This is what we want to have happen when we complete the square. We need to come up with a parenthesis that is multiplied times itself. Now, if you were paying attention, this parenthesis does not do that. This equation, sorry, it factors to this x minus 3 and the 2x plus 1. So what we're going to do is we're going to make this equation do what we want to. And the first step when you're making your equations do what you want to and you're completing the squares, you got to get rid of the 2. Divide everything by 2. And what you end up with is an x squared minus 5 halves x minus 3 over x 2 equals 0. The next thing you need to do is make a space for your perfect number. So you're going to move the parenthesis, or the number that doesn't have an x. So we now have an x squared minus 5 over 2x. You're going to leave a space, and then since I had a negative number on the left, I'm going to end up with a positive 3 halves on the right. Now I know those of you that don't like fractions are freaking out right now, but don't freak out. You have a calculator, do your fractions. Step number 3. No, we should probably write our steps down, huh? So we divided by any a we have. Then you're going to move your constant, your c term, and you're going to leave a space. Now, I call this completing the square. You're going to take that middle term, okay, and this is where you're going to divide by 2 with a number. Then you're going to take that number and you're going to square it, and that's the perfect thing that goes back into your equation. So negative 5 halves divide by 2, not a 3. Another review in fractions. Negative 5 halves divided by 2 is the same thing as multiplying times a 1/2. So if you divide negative 5 halves by 2, you get a negative 5 fourths. When I square that, I get a positive 25 sixteenths. So, in order to make a perfect parenthesis, my equation should have had a 25 over 16 here, but it didn't. So I'm just going to add 1. Now I'm allowed to do that as long as I add the 25 sixteenths to the other side as well. Now the next thing you're going to do is you're going to create your perfect squared parenthesis. And the way you do that is, we know we're going to have an x. I want a perfect squared parenthesis, and it's going to be another number here. Now, all you have to do is take the number that you got from the corner, that negative 5 fourths, and that's your perfect square, because negative 5 fourths times itself gives you that 25 sixteenths. Now the other side, you do have to add those two together, and when you take a 3 over 2 plus 25 sixteenths, you end up with a 49 sixteenths. And all I did was add those two fractions together. Common denominators, if you want to do this the long way. Fractions are not our focus, so if you just want to have a calculator do that for you today, that's fine. Now once you hit this method, we now need to get rid of the square, so we're going to take the square root of both sides of my equation. Now if I take the square root here and the square root here, the square root undoes the square, which is what I wanted to have happen. So the only thing I have left is the x minus the 5 fourths. Now if I take the square root of 49 and 16, I end up with a 7 over 4. But we have to include both of the fact that I could have had a negative or a positive in the first place. So you are going to have a plus or a minus version. Now what we just did in this blue step is called the square root property. So if you ever hear that word, that's what they're talking about, is taking the square root of both sides. It may be possible you'll see a question that says solve using this property. Now, once we have this formula, you've got to remember that quadratics, this one has two solutions. And they're going to come from the plus and the minus in this equation. So just solve them separately now. We'll have x minus 5 fourths equals a 7 fourths, and x minus a 5 fourths. It's going to equal a negative 7 fourths. Now from here, you just add 5 fourths to this side, and you end up with x equals 7 over 5 would be your 12 fourths, which is where your 3 comes from. And then when you add 5/4 to this side, you end up with x equals a negative 2 over 4, which is where the negative 1/2 comes from. So we still have an answer of negative 1/2 and 3. Let's go ahead and jump to the quadratic formula. Now, I do not know if this dude just wrote this quadratic formula on his neck or he tattooed it, but I thought it was funny. Now, we do have the quadratic formula. X equals opposite of b plus or minus the square root of b squared minus 4ac over 2a. Now, there are different pieces of this formula that you're going to need to be aware of. Now, first of all is that piece right on the inside. That's called the discriminant. Maybe we should tattoo the circle around his head too. Now that b squared minus 4ac is going to tell you how many solutions with an n, how many solutions, and it's going to tell you what kind. Having a spelling issue. What kind and the number of solutions. There we go. Now I can get that out of the way. That's what that is going to tell us. Now the way you can tell is you're going to go ahead and plug in your A, your B, and your C. And remember that 2 is the A, negative 5 is the B, and 3 is the C. And you're going to end up getting a number. Now, if your number is 0, you're going to get one rational root. And the reason you get the one rational root is because you've got an equation with a vertex that's just going to hit at one spot. That means your vertex is on your x-axis. Now, let's go ahead and move that one back. Sorry. Now, if you get an equation like this that lands at two perfect numbers, like this one that would land at a 2 and a 4. The only way you're going to get solutions like that is if you end up with a positive discriminant and it's a perfect square. Now I'm talking about 9, 16, 25, one of those perfect squares. Now if that happens, you're going to end up with 2 rational roots. Now there is another option if you get a positive answer. Now this would be a quadratic that does not hit at pretty numbers. It hits at any type of decimal. Now if you have any type of decimal there, what you're going to end up with is a positive discriminant, but it's not perfect. It should be like 8 and 15, and you're still going to get 2 answers, but you're going to have irrational roots. And what I mean by irrational is you're going to have square roots. The last situation comes from having a parabola that's floating way too high on your axes, which means it doesn't actually have any x-intercepts. We end up calling those basically non-real solutions. Now the way you end up with non-real solutions is you're going to have a negative discriminant. And I don't care if it's perfect or it's not. We have two non-real. You might also call them imaginary. Or you might see the word complex. It all means the same thing. All that means is that you have a negative number underneath your radical sign, which we know in the real world doesn't happen. Now, just a reminder, if I want to solve the quadratic formula, you've got to remember that the -1 under a radical, we just kind of keep going and change this symbol to this other symbol. It's like going from a capital A to a lowercase a. They look different, they mean the same thing. So the square root of -49 would just be an I and a 7. Because the square root of 49 is 7, the negative would give you your I. Alright, this is the rundown of the quadratic form, or all quadratic problems. If you need help solving any of these problems, or you want a more detailed description, there's about 5 other videos that go through all of these topics individually. So I hope this helped. Good luck on your test.